Welcome back to the class on over semiconductor drives. In this lecture, we are going to discuss about what are the different braking methods of a three-phase induction motor. Braking means intentionally or to decrease the speed of a induction motor. The braking methods of three-phase induction motor, basically there are three types are there: regenerative braking, plugging, dynamic braking. Again, under dynamic braking, AC dynamic braking, DC dynamic braking, zero sequence braking, and self-excited braking using a capacitor. Now, we are going to brief about each method. Regenerative braking. We know that the power input in induction motor equal to 3 Vs Is cos pi, where pi is the angle between the voltage and the current. Suppose if the machine is operating as a motor, then this angle will be less than the 90 degrees. Now, if you increase the speed of a motor above the synchronous speed, the relative speed between the air gap flux and rotor conductors will be reversed. Once it is reversed, the rotor current is reversed. Once the rotor current is reversed, the stator current also will be reversed because there is a transformer principle will be acting between the rotor conductors and the stator conductor. Once the stator current is reversed, the angle between the voltage and current is more than the 90 degrees. Nothing but a input power becomes a negative. The negative power is nothing but the machine is giving a power back to the source. This type of braking is nothing but a regenerative brake. For a fixed voltage and frequency, the speed of a motor should be greater than the synchronous speed for occurring of regenerative braking. Suppose if we have a source with a variable voltage and frequency, then if we decrease the frequency of the voltage applied to the induction motor, so the synchronous speed of a motor will be decreases, that we can make it below the actual speed of a motor, so that the regenerative braking will be occurs. Once the regenerative braking is occurs, the speed of the motor will be decreased. These are the speed torque characteristics of a braking operation as well as regenerative braking operation. See, this is the synchronous speed. Below the synchronous speed, if the rotor speed is there, it will be acting as a motor. If the rotor speed is above the synchronous speed, then it will be acting as a regenerative brake. These are the characteristics of a regenerative. Next, plugging. In case of plugging, we are assuming that already the motor will be rotating in one direction with one phase sequence. The phase sequence of the voltage applied to the induction motor, suppose if we take the RYB, if we change the phase sequence, then the rotation of the flux creating curve will be reversed. Once it is reversed, there is a rate of change of flux linkage with the rotor conductors also will be reversed. The direction of current in the rotor will be reversed. Once it is reversed, the developed torque in a rotor will be reversed. Once the torque developed in rotor is reversed, the speed of the motor will be decreased. This method is nothing but a like. Now here what is meant by phase sequence? Phase sequence is nothing but it is a sequence in which the phases are reaching the positive maximum value. In this method, interchange any two terminals of a running motor. So the direction of flux is reversed, the rotor current is reversed, and developed torque in rotor also will be reversed. Already the motor is running in one direction. So the speed of the motor is decreased. Whenever the speed of the motor is zero, remove the supply, otherwise the motor will be rotating in a reverse direction. These are the characteristics of a induction motor during the plugging. This is the motoring characteristics, nothing but if you apply the positive phase sequence to the induction motor, then these are the characteristics. Suppose if you apply the negative phase sequence to the motor, then this red dotted line is representing the characteristics up to here. If you extend this characteristic, we are getting the plugging characteristics. Nothing but this area is nothing but a plugging. Initially, the motor is operating at this point for given phase sequence RYB. If we change the phase sequence, nothing but we are maintaining the YRB. Any two terminal we change it. Here we change the R and Y phase is changed. Once the R and Y phase is changed, now the operating point will be shifted here. The negative torque is developed. Due to the negative torque, already the motor is running in one direction. So the speed of the motor will be decreases and slowly come to the zero. When the speed of the motor is come to the zero, some amount of negative torque is there. So the motor is trying to rotate in negative direction. But to avoid that one, to remove the supply from the motor. This method is nothing but a plugging. AC dynamic braking is obtained when one terminal is open or one terminal is connected to the other terminals of a three-phase induction motor. Suppose we have a one induction motor, we have given the three-phase supply. If we open the one phase, the remaining two phases are excited. Or if we connect the one phase to the other phase, it gives the AC dynamic break, which means that we are applying the unbalanced voltage to the stator of induction motor. That unbalanced voltage can be resolved into the positive sequence voltage and negative sequence. Positive phase sequence means the phase sequence which is same as the actual system phase sequence. The negative phase sequence means opposite phase sequence when compared to the actual system phase sequence. So the net, whenever we apply the unbalanced voltage, that voltage we can resolve into the positive sequence voltage and negative sequence voltage. Because of the positive sequence voltage and negative sequence voltage, the positive rotating flux and negative sequence rotating flux will be created within the induction motor. Because of these two fluxes, there is a torque developed in an induction motor. The net torque developed in induction motor is equal to sum of the positive sequence torque and negative sequence. Suppose if we increase the rotor resistance by external means, the negative sequence torque is dominating the positive sequence. So the net torque becomes a negative, so the speed of the motor will be decreases. These are the speed torque characteristics of a AC dynamic braking. This is the positive sequence torque. This is the negative sequence torque. Because the negative sequence torque is more because we added the some amount of resistance into the rotor circuit. The resultant torque becomes a sum of these two. This is the resultant torque. So the resultant torque is always negative. So negative torque is nothing but already the motor is rotating in one direction. The negative torque is developed in the motor means the speed of the motor will be decreased. Next, DC braking. In case of DC braking, the DC voltage is applied to the stator winding of running induction motor. See, this is the DC voltage, this is the stator winding. Any two terminals you can apply the DC voltage, or you can combine the three windings of stator. Also, we can apply the DC voltage. Whenever you apply the DC voltage, the DC flux is creating from the stator winding. Already the motor will be rotating. So, due to the electromagnetic induction, the voltage will be induced in the rotor. That voltage is driving a current through the rotor. If you waste that power in the rotor circuit, then the speed of the motor will be decreased. Now we are going to see the zero sequence braking. In a zero sequence braking, the three windings of stator winding we have to connect it in series. Apply the DC voltage or the AC voltage in this moment. Suppose if you apply the DC voltage, then steady flux will be creating from the stator winding. Suppose if you apply the AC voltage, coaxial flux will be created from the stator winding. There is a rate of change of flux linkage with the rotor conductor. The voltage will be induced in rotor conductor, which drives a current through the rotor conductor. If you waste that power in the rotor, then the speed of the motor will be decreases. This method is nothing but a zero sequence braking. In this class, we have discussed about what are the different braking methods we can apply to the three-phase induction motor. Thank you very much. If you have any doubt, you can ask me directly, or you can ask in the comment box of my YouTube channel, so that I am always available to answer all your